We're familiar with amides. We've been introduced to them in Chapter 12. And just as a reminder, amides are a functional group where we have an amine group, NH2 or NHR or NR2, directly bonded to a carbonyl carbon. And this slide talks about unsubstituted amides, and we know that as a primary amide. So unsubstituted means that there's no other carbon-containing group bonded to that nitrogen. So as with all molecules, the physical properties of amides are impacted by their intermolecular forces. And primary amides have two hydrogens directly bonded to the amide nitrogen, which enables them to hydrogen bond. And not only can a hydrogen bond, these hydrogens, which have a pretty partial positive, not only are they able to hydrogen bond with the nitrogen on another amide, they're also able to interact with the oxygen on that carbonyl. We want to remember that that carbonyl oxygen is a partial negative, and when hydrogen is directly bonded to nitrogen, oxygen, or fluorine, it's a really positive partial charge. So primary amides are able to effectively hydrogen bond. And we see this strong intermolecular force in their phases. All primary amides are solids at room temperature, except for the lowest molecular weight one, which is formamide, where that carbonyl carbon is bonded directly to a hydrogen instead of an alkyl or aryl group. And then low molecular weight primary amides are also soluble in water because they're able to hydrogen bond with the water, and amides are going to be soluble in organic solvents. So we can see the impact of hydrogen bonding when we compare the boiling point of acetic acid with a primary, secondary, and tertiary amide. The primary amide can hydrogen bond most effectively because there's two hydrogen directly bonded to the nitrogen. Secondary amide can hydrogen bond but less effectively than the primary amide, and tertiary amide cannot hydrogen bond at all. So if we look at a comparison with acetic acid, which we know can hydrogen bond, it has a boiling point of 118 degrees Celsius. Acetamide, which has a similar molar mass, has a higher boiling point at 222 degrees Celsius because of its enhanced ability to hydrogen bond as compared to acetic acid. N-methylacetamide, even though it has a higher molar mass, it has a lower boiling point because it only has one hydrogen on this amide nitrogen that is able to hydrogen bond. And N-dimethylacetamide, even though it has a higher molar mass than either of the other two amides, it has a lower boiling point because it is unable to hydrogen bond. And finally, let's take a look at some of the chemical properties of amides. So we would think that because amides have this nitrogen with a lone pair on it, they would be basic. But actually, this polar carbonyl group really impacts the chemistry of this nitrogen, and amides are not basic. Amines are basic, and amides are not.